So welcome everybody to this latest GCSE revision video on 162 Maths, and in this video we'll be going over another AQA topic test on the high syllabus with a focus on real life graphs. Now there will be a copy of the set of questions I'll be going through in the description below for you to download and have a go at before watching this video and going through the answers. So let's get started on this AQA GCSE Maths topic test on the higher schema work or real life graphs. So looking at question 1, it says this graph shows the relationship between the width of W centimeters and the length of L centimeters of a rectangle with a fixed area. Write down the width when the length is 5. So what we need to do here is simply find where L equals 5, which is at this point here. We find out where it touches the curve, and then we just want to read off whatever value that is there, and that value I would say is around about 7.5. Now, obviously, in terms of, let me just get rid of those dots, and see that it's at that point there, so we just project across, and that goes to 7.5. It then says work out the fixed area of the rectangle. So all we need to do here is basically just simply multiply those two numbers together. So if I then do 5 times 7.5, it should give me an answer of 37.5 centimeters squared. And for C it says when the area and the length are equal, so when the length and the width are equal, the rectangle is a square. Use the graph or otherwise to work out the length of the side of the square. Clearly show how you have obtained your answer. So for this, all we need to do is look for L and W, so where they're both equal. So if we look at drawing L equals W, we look at 0, we look at 5, we look at 10, and we look at 15, 15. And what I then want to do is to draw a straight line through those points and try and do it as accurately as possible. And what we're looking for is where this green line crosses the curve on the graph, which is at this point here. And so what the question is looking for, asking us, is what is that length? And so either using the horizontal or the vertical point, I work it out to be around about 6.1. So any of those answers, I would say any answer between 6 to 6.3 centimeters should be absolutely fine. Then looking at question 2a, it says this graph shows the first class postal rates, and it says that this graph is called a step graph. Explain why a step graph is used to show the postal rates. So for this, a typical answer would say that there is a fixed price for a range of masses or weights. And so something along those lines would be absolutely fine. Now with question 2b, it says Mel has 5 items to post to the same address. They have masses of 125, 125, 125, 240 and 600 grams. They can be set separately or combined together. Work out the cheapest way to send the items for 3 marks. Now this question, there could be several attempts, and all you want to kind of show is at least one, but being the cheapest. And the cheapest way of doing this is by combining the 125 grams plus 125 grams plus 240 grams, and then which comes up and then as one package. So adding all of those up, we get 125 plus 125 plus 240, and that comes up to 490 grams. And sending a parcel of 490 grams will cost £1.68. So that equals £1.68. And then sending the remaining one, which is 125 grams plus 600 grams, which comes up to 725 grams, and that's going to cost, to send a parcel of 725, £2.42. And then if I just simply add those two amounts up, so 168 plus £2.42, it comes up to a total cost of £4.10. Then moving on to question 3, it says here are 4 chemical flasks and each flask is filled with water at a constant rate. Match the mask to the graph that's showing the depth of water against time. Now in terms of this, the actual answers we should have, let me just zoom out a little bit so we can actually see the graphs and the actual answers. Let me just scroll down. Oh, there we go. So in terms of flask A, which looks like that, then that should be graph B. The next one is F, next one is A, and the fourth one is C. And again, all we just need to look at is basically with graph A, it's going to be slow to fill up and then it starts to speed up, which is why that is this one here. So that's number 1, or A. For flask B, that's going to be consistent, so we're looking for F, and that's the only one that gives us that constant rate. Now it could be D, but again the problem with C, is the fact that it's going to be filling up slower, and so that means that D is going to be C, and leaving us with our final one, which is C, which is quick to fill up and then it starts to slow down and then it gets up again, and that's basically what A is, so that there is C. Then moving on to question 4, it says that here is a graph and we've got distance against time. So what is represented by the gradient of the line, and that is basically going to be speed. Then in terms of the units, well, the units of speed is going to be distance over time, so it's going to be meters per minute. And again, if you wanted to actually write down, say, meters per minute, then that would be absolutely fine. I certainly wouldn't leave it as M over M. I don't think that'd be worth any marks, but again, you just want to kind of identify it as meters per minute is what you're trying to aim for in your answer. Now for question 5, it says that Tyler uses a graph of C equals 0.25t plus 20 to work out the charge in C pounds for the job that involves fixing T tiles. Work out the gradient of the graph. Now the gradient of the graph here is going to be 0.25 for 1 mark. Then says, what does the gradient of the line represent? Well, that's going to be the cost of fixing each tile. And then the question then says, what does the constant term represent? Well, that's going to be the fixed cost, or you could have it as what we call the call out charge, like so. So looking at question 6, it says that here are 2 conversion graphs, and the first one is litres to UK gallons and the second one is UK gallons to US gallons. Now the information in the question, it says that petrol costs £1.19 per litre in pounds, and petrol costs $2.70 in the US gallons in the US, and the conversion we've got is £1 equals $1.56. George buys 3 US gallons of petrol, and the question is asking is how many times more would the equivalent amount of petrol cost in the UK. So the first thing let's work out is, let's have a look at the US price. So US price, and it's going to be 3 times, and it's 3 gallons, so it's just 3 times 2.7, which is $8.10. Now in terms of the UK price, or the costing, let's have a look. So 3 US gallons going up is the equivalent of 2.5, so 3 US gallons is equal to 2.5 UK gallons. Now 2.5 UK gallons is going to be roughly around about 11, so 2.5 UK gallons equals roughly around about 11.5 litres. Now in terms of the cost, well, it's going to be 11.5 times 1.19, and so 11.5 litres, so 11.5 times 1.19 comes up to a cost of £13.68 and half pence, which is not priced, but we're going to then convert it. So then if I then do 13.685 multiplied by the conversion rate of $1.56, so times 1.56, it gives me an answer of $21.3486. So what I then need to do is compare these two amounts in terms of how much more bigger is it. So it's 21.3486 divided by 8.1. If I do that on my calculator, I get an answer of around 2.6356, blah blah blah. So in terms of how many times bigger, I would say it's roughly around about 2.64, and that's to 2 decimal places.